Hello everyone. Today in this video clip I'll be talking about two new things. Now of course, sequences and series. This is in section 9.1 of our textbook. So let's start with the first one, sequence. Make it easy for you all. Just think of sequence this way. Sequence is a list of numbers. That's it. That'd be pretty simple. It's not like a formal definition, but at least it's help you to figure out what a sequence is about. It's a list of numbers. Formally, people define sequence this way. This is a function where the domain is the natural number. It's like counting from 1, 2, 3, 4, 5, or 0. But, I think it's easier to think of it. It's just a list of numbers. Okay, this is a sequence. So this is not a formal definition. Let me put this in a quotation mark. List of numbers. Okay, example. This is what we call a sequence. Bunch of numbers. 2, 4, 6, 8, 10, da da da. And you see the pattern, you can guess. The next number will be 12 because I'm talking about even numbers. How about this? 2, 4, 8, 16, 32, da da da. And the rule for the second one, this is also another sequence, okay? And the rule for this sequence is what? You keep doubling the previous number to get to the next one. So 2 times 2 is 4, 8, and 8 times 2 is 16, so you double is 32. And so for the second sequence right here, we keep multiplying by a constant to get to the next term. Here, what? We keep adding 2, right? How about another sequence? How about this? 5, 5, 5, 5, 5, da, da. Of course, the next number is going to be also another 5, right? This actually we call it a constant sequence. How about another one? 1, negative 1, 1, negative 1, 1. You can guess the next one, right? Alternating. See what else? Oh, how about this? This, but a good one. 1, 1, 2, 3, 5, 8, 13. Later on, we know that this is called Fibonacci sequence. We get to the next term by adding the previous two terms. Because given the first two terms, 1 and 1. Then the third term, starting from third term, is what? 1 plus 1 is 2. You got the third term, right? And then how do you get to the fourth term? 1 plus 2 is 3, and similarly 2 plus 3 is 5, 3 plus 5 is 8, so forth and so on. You can construct a sequence that way. And of course more, but those are a couple of examples. And in this first section, 9.1 of our chapter 9, we just try to introduce you the idea of sequence and series. And later on the coming up sections in 9.2 and 9.3, we're going to learn some specific sequence and series, arithmetic and geometric sequence and series. Okay, so the first one right here, if you keep adding a constant to get to the next term, see, I'm adding 2, keep adding 2, plus 2, right, keep add 2, keep add 2 to get to the next term. This is called the arithmetic sequence. Sequence. And this one, instead of adding, now what do we do with the second one? We keep multiplying by 2, right? So this is what? Geometric sequence. Alright? So actually the third one right here is both. You can think of this could be an arithmetic. You think of what? Adding 0 to get to the next term. And you can think of what? Multiply by 1 to get to the next term. So it could be both at the same time, and actually it's all 5 to people usually call it a constant sequence. Constant sequence. Okay? And this one, 1, negative 1, 1, negative 1, you see what happened in here? The sign keep alternating, right? So alternating sequence. Alternating. And this have a special name, so this grid is Fibonacci, so Fibonacci. Alright, so at least for now we get some idea of what is what a sequence is about. It's just simply think of a list of number could be adding to get next term with multiplying, could be constant, alternating, or Fibonacci, or many more type of sequences. All right. At least we have some example right here to help you to figure out, at least have an idea what it means by a sequence. All right. And usually people denote sequence by this. I'm talking about notation now. Say A sub n in parenthesis. Let me see. Our book use curly bracket, I think. So let me use curly bracket. Curly bracket. Say n start from 1 to infinity. Okay. Or sometimes, say many times, people can start counting from 0. So you can see some other book can start from 0 to infinity. That means what? We have A1, A2, A3, A4, A5, da 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 da. See? And it's a carry number, start from 1 all the way to infinity. So 1, 2, 3, 4, 5. So if you have a sequence, let me just use the first one right here. 2, 4, 6, 8, 10. It means what? This is A1 is 2, and A2 is 4, A3 is 6, A4 is 8, A5 is 10, so forth and so on. Okay? And you have the notation of a sequence in curly bracket, and then n here is the counting index, start from 1 or 0 to infinity. So the first term is A1, and if you start with n equals to 0, then the first term is A0, and then A1, A2. Okay? And learning about sequence, there are a couple of things that we care about. First question, can we find the general formula for the sequence? So in this particular example right here, the general formula is an is equal to 2n. Check it out. Look at n equal to 1. And a1 is equal to 2 times 1. So n equal to 1 equal to 2. Yeah. A2 is 2 times 2 equal to 4. A3 equal to 2 times 3 equal to 6. So forth and so on. So the general formula will help you to calculate the n term. Okay. All you need to know is the position of that term. Say n here, n is counting random position. Say you're going to calculate a 100. You plug an n equal to 100. You know that a 100 is equal to 200. Okay. And this general formula is one of the things that we need to learn to find out. And of course, in general, sequences are hard. All right. So we'll learn some basic ones, some fundamental one first, and this is one of those, the arithmetic one, or the geometric one. All right. And in case that you cannot find the general formula, we have another formula called the recursive formula. Recursive formula. So the next term will be calculated based on the previous term. In this one, we need to know the first term, all right, the initial term. So in here, I give you this: a1 is equal to 2. A1 is equal to 2. And I'm telling you this: an, so the n term is equal to an minus 1 plus 2. What am I talking about in here? I say what? You can calculate the n term by taking the previous term at 2. You see? So if I got the first term, a1 is equal to 2. How do I calculate the second term? 2 plus 2, I got 4. Now I got a2. So a1 equal to 2. a2 is equal to a1 plus 2, which is 4, right? Now that I got 4, how do I calculate a3? I take the previous term, which is a2 plus 2. So a3 is equal to a2 plus 2, which is 6. 4 plus 2 is 6, so forth and so on. So if you have a formula telling you that given the initial term, could be 1, could be 2, and then what? And could be more, but some initial terms, all right? And then they give you the recursive formula. The n term is calculated based on some previous term, and this is called the recursive formula right here. Okay, and you can use this for the Fibonacci. Okay, so let me erase it. Point to write down. So for Fibonacci right here, I'm giving you what? a1 is equal to 1, and a2 is equal to 1. And the recursive formula for Fibonacci is this: an, the n term, is equal to the n minus 1 term plus n minus 2 term. Right? What is saying right here? I'll give you the initial conditions for the first two terms. A1 is 1, A2 is also 1, which are the two terms right here, 1 here and 1 there. And starting from n equal to 3, the next term will be calculated by adding the previous two terms. So A3 is equal to A2 plus A1, right? A3 is equal to A3 minus 1 plus A3 minus 2. This is A2, this is A1. And this 1 plus 1, you got 2. 1 plus 1 is 2. Similarly, A4 is A3 plus A2. And you got 3, and so forth and so on. Alright, and this is called the recursive formula. So I'm on the two formulas that you just seen, the general formulas and the recursive formula. I claim that the general formula is more powerful because you don't need the previous term to calculate the next term. All you need to know is n. And you can have it anytime you like. Okay. That is about the formulas. Next, let me try to show you some notation or some notations that would be helpful when you guys learn about sequences and series. So the first one is called factorial notation. It's denoted this way. It's just exclamation mark. So if you see n factorial, and what does that mean? N times n minus 1 times n minus 2 all the way to 1. Okay? For example, 5 factorial means 5 times 4 times 3 times 2 times 1. Oh, I say 1. Okay? And of course we can calculate it. This is 120. So 3 factorial is 3 times 2 times 1, which is 6. Of course, 1 factorial is just 1. And by invention, alright, 0 factorial is equal to 1. Okay. The next type of notation that you guys are going to find out is going to be very useful for your learning is the summation notation. Summation notation. Right? It's denoted by sigma, this one. This is the S in the Greek alphabet, okay? So, did you know you have sigma of, say, I run from 1 to 5. What do we mean by this? We mean this is what? We plug in I here called the counting index, okay? I start from 1 and 1, 2, 3, 4, 5. So, and sum is sigma. So A1 plus A2 plus A3 plus A4 plus A5. Okay. So if you see this, sigma of Bj, where j runs from 3 to 6. So B is whatever it is, and j here start with 3. So we got plug in j go to 3, I got B3. Okay, and that's sigma notation means that you add and then keep increasing j by 1. You got what? B3 plus B4 plus B5 plus B6. We stop right here. J went from 3 to 6, right? And that is what the notations of summation means. Let me give you a couple more examples. How about this? Sum of 3n and run from 1 to 4, for example. 3 times n, right? So that means what? 3 times 1, because I plug in n equal to 1, and then plus. Now I got to increase in n by 1. This is n equal to 1. Increase in n, I got n equal to 2. The next I'm going to be 3 times 2. And now move on to n equal to 3. I got 3 times 3. See? N is 1, 3 times 1. N is 2, 3 times 2. N is 3 times 3. And how long are we going to go? All the way to n equal to 4. 3 times 4 is n equal to 4. And then you can calculate the sum. In this section right here, I was just trying to show you the notation, summation notation. That's what it is. Okay. And of course, if you have a finite sum, means what? It's come up to a finite number up here, then you can have some formulas involving a couple of summation. Say I got sigma of A I run from 1 to n plus sigma of BI I 0 from 1 to n is going to be sum of AI plus BI I run from 1 to n. Then the first one is this A1 plus A2 plus da 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 all the way to AN. And then the second one is what? B1 plus B2 plus da 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 all the way to Bn. Saying the two sums are finite, you guys can reorder those terms. So the A1 plus B1 plus A2 plus B2 plus da 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 all the way to AN plus Bn. And this is what you got. Okay, I equal to 1 to n. Okay. Similarly, one more. Property of the summation sum. Say if you have the sum of k times ai, I run from whatever, say 1 to n. And by the way, this means what? K is a constant, alright? So k times a1 plus k times a2 plus all the way k times an. And what I claim is you can bring the k constant outside the summation. And why is it? You can see that everything got a factor of k, right? So factor out the k, a1 plus a2 plus all the way to an. And of course this is k times, this is a sum. ai. I run from 1 to n. Okay. More. I think it'd be easy if I give you kind of half example, half formula. If I got something like the sum of AK, say k run from 1 to 7. And by the way, what does it mean by this? This is what? A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7. Okay? I claim that this sum can be broken out as what? Sum of AK, k run from 1 to 3 plus sum of AK again, but now k run from 4 to 7. For example, of course, it's just an example. You can use any number in general. You can say n in here. What we're trying to say in here is what? The sum of 7 terms from 1 to 7 can be broken out with the sum of the first 3 terms, and then the sum of the last 4 terms. This is AK 1 to 3, and then AK 4 to 7. Okay? So in general, it would work for anything. Okay, that is about sequence. And just some basic definition, some basic idea. We're going to learn in detail later when we move on to the next section. All right. Now let me move on to the next sum called series. Now that we have the sequence already, we construct a series this way. We add all the terms of sequence together by adding all terms of a sequence. Again, this is not formal definition, but really this is the idea. So let me put in quotation mark. Okay? So, say I got a sequence. A1, A2, A3, A4, da 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 da. Okay? We're going to add all the terms together, denoted by S. Think of S, and for series it could be sum. Okay? This is what? A1 plus A2 plus A3 plus A4 plus whatever. Okay? This is called the sum of all the terms, right, of a sequence, called the series. Okay, we have a couple cases in here. If S is a finite number, so if S turn out to be finite, then we say that the series is convergent. Okay? If S is equal to infinity or undefined, so infinite, then could be equal to infinity or could be undefined. Okay? Infinity or undefined. And we say that the series is divergent. Now you may ask, how in the world are we going to add infinite terms to come up with a finite number? The idea is going to be clearer when you take one. I think talk about limit, that'll be easier, but at least for now I can give you an example, show you that if you add something forever, it could be a finite number. Example, I start with a sequence, okay? 1, 1/2, a quarter, 1/8, 1/16, da, da, da. You see how I construct the sequence? 1, start with, okay? And then what? A half. Cut it in half, right? And then 1/2, cut it in half, I got a quarter, divide by 2 again, I got 1/8, divide by 2, I got 1/16. Over. And then add them up, 1 plus 1/2 plus a quarter plus 1/8 plus da, da, da. It's going to be equal to 2. Or at least approaching 2. The easiest way in my opinion to explain to you guys how that add up equal to 2. Think of number 1 is like a square. Okay, this is 1. 1/2 is a half of the square. A quarter is a quarter of a square. Okay, 1/8, 1/16, 1/32, 1/64. You keep adding up, what you see is 2 squared, which is 2. And now we have the idea of series. Now let me talk about the one last thing for the day, partial sum. Okay, what if the we cannot add up forever, but at least we can add just partial of the sum, add a finite many terms. Okay, so I'm going to erase some in here. Something called partial sum. Right. But if we recall that S is the sum of all the terms, right? Partial sums, we're going to put a subscript n right here. Sn right here, it means A1 plus A2 plus A3 plus da 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 up to An. So this is the sum of the first n terms. 1, 2, 3, 4, all the way to n. Okay? And this is what, using summation notation, right away, it's going to be A, I run from 1 to n. So you have it, right? With that, the idea of partial sum, so Sn is sum of first n terms, so S1 is just A1, one term, okay? S2 means what? The sum of the first two terms, so A1 plus A2. And keep in mind, in here, I use 1 as a first term. And don't be surprised if you read other books, they use 0 as the first term, so S2 is really what? A0 plus A1 plus, plus A2, so actually 3 terms, okay? All right, and then S3 is what? A1 plus A2 plus A3. So S4 is A1 plus A2 plus A3 plus A4, 3 row. Sn is A1 plus A2, A3 all the way to An, all right? And then You can think of this one as infinity. It's actually denoted by S is what? A1 plus A2 plus A3 plus da 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 forever. We don't have the answer go to infinity, and this is really your series. Sum of AI iron from 1 to infinity. Okay. And this is the end of section 9.1. My job in this section is to introduce you guys what it means by a sequence and series, and some useful notation that we're going to use quite a lot for sequences and series, which are the factorial notation and the summation notation. Hope that this video clip is helpful for your learning. And as usual, if you have any question, please don't hesitate to ask. Thank you for watching. Have a good day, guys.